Hello students, today we are going to solve this question. In this question we have to calculate the limit of the function such that the function should have non-zero finite value for a particular value of n. So we have to calculate the value of n. If you observe, if you apply the x equals 0 in the given fraction, then you will see that the expression in the numerator approaches to 0 as x approaches to 0, and the expression in the numerator also approaches to 0 as x approaches to 0, which means the given fraction is in the form of 0 by 0 indeterminate form. And also this. So in order to solve this problem, we will apply the L'Hospital rule. So in this rule, what we will do, we will differentiate the numerator and denominator with respect to x separately, and we will then apply the limit to check whether the limit exists or not. So if you differentiate the numerator part, you will get 1 plus cos x minus cos x plus x sin x minus 6 square x divided by n x to the power n minus 1. So we are applying the power rule over here. So if you apply 0, you will see that the term in the sine form tends to 0, and the one plus cos x minus cos x gets cancelled up, and sec square x will be equals to 1, so 1 minus 1 will be 0, which means that this term, this fraction will also tends to 0 by 0 form. So this is also indeterminate form. So again we will apply the L'Hospital rule and differentiate both numerator and denominator with respect to x. So when we apply this, we will get so this was what we will get, and we will again apply the limit, and you will see that those terms in the tan x and those in sin x gets to 0, and since the x cos x has the x as a multiple, so x also tends to 0, which implies that x cos x will be 0 as well, which means this is again in the 0 by 0 format. Now what we will do, we will again apply the limit L'Hospital rule and differentiate the numerator and denominator with respect to x again. So now if you apply the limit, then you will see that this term gets to 0. The term with tan will also gets to 0. Sec to the power 4x is equals to 1, and cos x when x is equals to 0 is also 1. So if you combine these two, this will also gets to 0, because 2 cos x minus 2 sec to the power 4x is equals to 0 when x is equals to 0. So this is again 0 by 0 form. So now we will apply the limit again, L'Hospital rule. So we will get limit x tends to 0. So it is divided by n. So now we will apply the limit and check whether the values are finite or not. So the sine term will get cancelled. The sine terms will get to 0. The tan term will also get to 0. And since x is multiplied with cos x, so cos x times x will also be 0 due to x equals 0. So this is again 0 by 0 form, and we have no solution yet. So we will again apply the L'Hospital rule. Why we are applying continuously L'Hospital rule? Because our aim is to obtain a finite value which is non-zero. So far the limit does not exist, it is in indeterminate form. So we will try to find out some value after certain L'Hospital rules. So we will again apply the L'Hospital rules to the numerator and the denominator as well. So let us apply. So I'm not differentiating the after differentiating, some of the terms will be in the tan terms. So I'm just taking the common tan from the rest of the terms. n minus 3, n minus 4, x to the power n minus 5. So now what we will do, we will again apply the limit . So when we apply, we will see that the numerator is not getting 0. It's negative, some value will be there, that is minus 16. So we will have the finite value at this point if this value is equals to 1. It is equals to 1 if x to the power will be equals to 0, so that x to the power 0 is equals to 1. So what we will do, we will equate n minus 5 to 0. Which will give you the value n equals 5, which implies our correct answer is 5. Thank you.